Hi everyone and welcome to this, my video on the sine rule. Now it's part of the general maths course over here in Australia, but believe it or not, it's actually all over the world. It's used all over the world, so hopefully this video will find you well and it'll be useful. Now my name is Darren from mathsguru.com. Yes, mathsguru.com, that little corner of the interweb where all these videos are, downloadable notes, VCAR questions, exam stuff, and so much more. Hopefully you'll head over there. It's absolutely free to sign up and it'll be hopefully useful. Before I go any further, do me a favour, can you subscribe to my YouTube channel? I would cry on demand, but I can't. It's just not something I can do. It stopped my acting career. But I'm not going to cry. It's just every time you subscribe or someone subscribes, it just sends that little ping to me and says, hey, someone's watching your video. Please continue doing it. I'm sitting in a room on my own at the moment. The dog's licking himself. Not inappropriately, I didn't say that, let's not go there, yeah, and he thinks I'm mad because I'm talking to myself, but subscribe, that would be greatly appreciated. Right, what am I going to do in this video? Well, yeah, it's there basically. You can pause the video and have a look if you need to, but I'm just going to go over what the sine rule is. Now, it's building on a whole chapter of work relating to pretty much trigonometry. We've done the basics, we've looked at side lengths and angles and bearings and all those type of things as well. And now we're going to get on to the fact of non-right angled triangles, because all that rest of that stuff dealt with right angled triangles. But not all triangles in life are right angled. So let's see what we can do to help us find missing sides and missing angles. Now, this whole topic sort of deals with making sure that you got the sides of a triangle labeled correctly. And I get very nervous when I actually say that, because the formula that I'm going to show you in a moment is a little bit prescriptive. It sort of confuses people. So what I need you to know is that whatever this angle, this side length here is called, the opposite side has the same letter, but generally lowercase. So this angle here might be called C, and then this little length here, this length opposite it, is little c. This angle here is B, its opposite side length is little b. Angle here is A, its opposite side length is little a. So that's really the important thing to say. Let's not get too sort of caught up on the idea that that top angle always has to be called A, and this one down here always has to be called C. It doesn't matter. All you got to notice is whatever that angle is there, its opposite side has the same letter. And that's going to become really, really important. We've already sort of met that in trigonometry. Now, I'm going to go straight to the formula. It really doesn't matter where it came from. Higher order maths, and to be brutally honest with you, I've taught for like 147 years. I still don't know where it comes from, and if I'm honest with you, I don't really care. I know how to use it. I don't need to know how a microwave works. I just know how to press the buttons. Yes? Exactly. Right, so here we go. So this formula seems a bit weird. For the first thing, we've got two equal signs in it. We've been telling you through your whole life you cannot write things with two equal signs in, and suddenly we break the rules with a sine rule. Okay, we'll deal with it. The reason it's got two equal signs in it is because actually we only ever use two parts of the formula. We either use that first half, or we might use this second half, or we might use this be equal to that. Again, that'll make a bit more sense in a moment. So you're generally speaking never going to use the whole thing. We're not going to end up with two equal signs. Your calculator's not going to have some sort of a nervous breakdown, but the point of it is, it's there. Now, when do we use the sine rule? We use it when we are given two sides and one angle, or two angles and one side. Now, generally speaking, going back to this, for the sine rule, we'll always be given an angle, its opposite side, and one other piece of information. The sine rule works the best when I have an angle and an opposite side and one other piece of information. Again, that'll make sense in a moment. So it's probably easier to do some examples and show you how it works. So there's another rule coming up later on called the cosine rule, which is awesome because that helps us find angles in slightly different ways. But the trick to knowing when to use the sine rule is, do you have an angle and an opposite side? And in this situation I do, so I already know I'm going to use the sine rule for this. Now I generally will always write down my formula first. So I've got A over sine of A equals B on sine B equals C on sine C. Formula, because I always remember I do formula, then I do substitute, and then I'm going to use my calculator to solve it. So now again, the A, B and C is just for the formula. But what I remember is this really here is just a side and its opposite angle. So I'm going to choose these two together and I'm going to match them up. So let's say that my little a is 7. So the side length is 7 divided by the sine of the angle. All right. And again, the angle is always the thing that goes with the sine. That's why it's called the sine rule. I'm going to do equals. Now, I've got another side. I've got this side here. So that's going to be 6. And I'm going to divide it by its angle. Well, I don't know what its angle is. And as it turns out, this is the angle we're going to try and find the size of. So I'm now going to do divided by the sine of B is equal to, and I'm just going to show you why this doesn't work. Do I know the side length of C? They haven't given me that information there. They haven't given me the angle. So I don't actually need to use that bit. I can't use it. And there we go. Now, again, there's lots of ways of doing this. Some of your teachers may turn around and say, right, I want you to rearrange it and then do it the hard way. I'm not going to do that. I'm going to use my NSolve on my calculator. So NSolve in brackets, 7 on the sine 120 equals 6 on sine of B, comma, B. All right, so that's what I've written it out. So let's fire up my calculator now and see what happens. So menu. Oh, I've done it again. Bear with me, guys. Let's clear that down because I've been doing that in a previous thing. Cancel, actually do the right button. No, I don't want to save it. Now, again, thing to notice here is that this only works for general maths if your calculator is in degrees mode. And what do you notice? My calculator is actually in rad. So if I go up to my calculator and hit enter or click it, it changes to degrees. If you're using the class pad, again, I can't quite remember how to do it. I don't think it's that difficult, but I'm just going to show you how to do it on here, hoping that you'll be able to work out the sort of functionality on the class pad. Right, a menu, algebra. I'm going to do NSolve, which is numeric solve. And then I'm going to basically do my that. So it's going to be 7 on. Now, where's the sine? It's in my trig button. So there's sine of 120. Hit right arrow, hit equals, and then do another fraction. And what have I got? 6 on the sine of trig, sine of B. I don't know what B is, so just on the, and then I'm just going to do comma B. Hit enter, and lo and behold, out comes the value of 76.928. It wants you around to one decimal place. So, sorry, 47.9. So we're going to do 47.9. So therefore, B is equal to, or capital B is equal to 47.9 degrees. All right, I don't know why I got that 76 point something. My brain is really fritzing today. But there we go. We found angle B, 47.9 degrees, just by using our formula and being able to substitute in the right way. All right, find angle B, correct to one decimal place. And again, I'm firstly going to check, is this a sine rule question? I have an angle and I have its opposite side length. So as far as I'm concerned, probably the sine rule is going to be the best thing to use for this one. So let's now use my formula. Greatly put in my summary book. So I've got A on the sine of A equals B on sine B equals C on sine C. And again, I'm going to write that for the moment, but yeah, all I'm interested in is, do I have a side length and an opposite angle? That's what it means. This is literally saying a side and its opposite angle. So I've got a side length of 6 divided by my opposite angle of 47. So that's the sine of 47 is equal to, I've got a side length of 5. Do I know its opposite angle? No. So that's going to be the sine of B again. Do I need this part of the formula? Nope. And there we go. So I've got my formula. What am I now going to do? Well, once again, I'm going to write NSolve. And I'm going to do 6 on sine 47 equals 5 on sine of B, comma B. Put it in my calculator. Now, obviously, when I bring my calculator, it's going to obscure things. So we've got menu, algebra, numeric solve. Again, let's do my brackets, or my fraction thing. So that was 6 on the sine of 47. Right, equals fraction 5 on the sine of B. And then comma B, so the calculator knows what it's got to do. 37.55, one decimal place, 37.6. So So there we go, in which case we would have, therefore, B is equal to 37.6, and don't forget your degrees. See what we're doing here? Banging it into a calculator, sorry, banging it into a formula, and then letting your calculator do all the hard work. Ooh, find angle C in the triangle shown to 1 decimal place. Right, let's see. What do we got? What do we got? What do we got? Do I have an angle and a side? Well, we haven't been given the side, but that's okay. That's what we want to find. Let's go through my formula then. So we've got A over sine A. Now again, this is where I'm sort of hoping you guys will understand that I'm not really bothered about the A on sine A, B on sine B. I'm just linking up opposite sides and their given angle. So in this situation, I'm going to write C over the sine of 50. The reason I'm going to write that is because this is what I'm looking for, and those two sort of link together. Right, is equal to, I've got this B. Oh, I don't have that angle. Oh, that's okay. I obviously don't need to use that one. I've got 100. Oh, hold on a moment. And this is where a question's thrown a bit of a curveball, because they're trying to trick you. But the trick is relating to, what do you notice? I've got 2 angles in my triangle. That's not that tricky. Because if I know my 2 angles in my triangle, can I find my third one? Absolutely, because angles in a triangle add up to 180 degrees. So 100, 150, that angle there would have to be 30 degrees. Now, I've got a side and an angle that are joined together. So again, so I'm going to do my side length, which is 8, divided by the sine of 30. Have I got what I need? Yes, because basically here, I've only got one thing I don't know. So because I don't know that, I can now end solve it, end solve, comma, C on sine 50 equals 8 on the sine of 30, comma, C in this case, because that's the thing I don't know. Fire up my TI Inspire, and let's see what we come up with. All right, menu, sorry about the clicking, menu, algebra. Nope, my calculator's gone slow. My calculator hates me today. All right, menu, algebra, end solve, right. Fraction, if you will, be so kind. So C over, I'm just going to type it, guys, because it's quicker for me to type it than hit all the buttons. Equals 8 on the sine of 30, comma, and this situation C, hit enter, and out comes, find the side length shown to 1 decimal place. So that 1 decimal place would be 12.3. So in which case C would equal to 12.3, and what would we be looking for? Units. They didn't give me the units, so in which case just 12.3. Again, all you're doing is you're matching angles, opposite sides, angles, opposite sides. Use the ones that fit the question the best. Right, find A to 1 decimal place. Again, are they trying to trick me here? Well, I have an angle and an opposite side. I have a side but no angle. I've got an angle but no side. So they must be trying to trick me here. So there we go. I've got 48 and 85. So if I just do my calculator off to one side, I'm going to do 180 minus 48 minus 85. Hit enter. Tells me that that angle in there must be 47 degrees. And now I have a side and an angle that are given. So I'm going to do that first. So I'm going to say then in which case that 10 divided by its partner, the sine of 47, is equal to, what are we trying to find? We're trying to find A, so we've got to use that joint angle there. So A over the sine of 48 degrees. Do I have everything I need? Yes, I do. So I'm going to end solve that. So I'm going to end solve. I'm not going to write it all out, but comma A, and again, fire up my calculator, and let's see whether it likes me a little bit better this time. All right, so menu 3, 6, and solve. And again, I'm just going to type it because it's going to make my life a lot easier. 10 over the sine of 47 equals A, oops, A on, oh my goodness, come on, A on the sine of 48. Comma A, let's just check we got that right. 10 over sine 45, 7, equals A over sine 48, comma A. And because it's a side length, 1 decimal place, 10.2. All right, so in which case, in that situation, A is equal to 10.2 units. They haven't given it to me. Leave it at that. Now, as it turns out, we turn the maths and we try and make it a little bit more like real world, don't we? We try and throw in the idea that now, well, we've got trees and we've got rivers and lakes and all this type of stuff. But it doesn't matter about the application. In many cases, what we're looking for is a triangle and then the right rule. So here we go. Do they happen to have already drawn a triangle in here? They have. Thank you very much. So let me see. Leo wants to tie a rope from a tree at point A to a tree at point B on the other side of the river. He needs to know the length of rope required. So we've got to find that length there. So I'm going to put on there a little C. Why am I putting on a little C? Because it just so happens to match that capital C there. Now, when he stood at A, he saw the tree at B at an angle of 50 degrees. Oh, there we go, 50 degrees. After walking 200 meters to C, so they're giving me that there is 200 meters. The tree was seen at an angle of 30 degrees to the riverbank. They give me this angle here. Find the length of rope required. So we've got to find this. Marvelous. Have we got its opposite angle? We do. Good. So the first thing I can write is that we've got C on the sine of 30 degrees is equal to. Now all we need is an opposite side and an angle. Well, they've given me a side length here of 200. So I just need to... Oh, not again. What are they keep? What? So we already know that that's now going to be 200 divided by the sine of what angle? Well, they haven't given me the angle. They don't tell me the angle. We run around, we panic a bit, and then we go, nope, because we know that's 50 degrees, that's 30 degrees, 80 degrees in total. Angles in the triangle add up to 180 degrees, so that there must be 100 degrees. So there we go, 100 degrees. I have all that I need to know. Firing up my, oh my goodness, my calculator again. Menu, algebra, numeric solve. We can do this now, almost in our sleep, which would be embarrassing because I tend to dream, but not of maths. So that's sine of 30 equals 200 divided by the sine of 100, not 1000, comma, C, hit enter. And there we go, 101, what does it want? 2 decimal places, 101.54. So therefore, C is equal to 101.54 units meters. Now, whenever I get an answer, I always check what I call the reasonableness. Because does it make sense for that to be about 100 meters? Well, that's 200. I mean, obviously, if that was like 900, I'd begin to panic. Probably would have made a mistake. But 101 sort of makes sense in my head. Seems reasonable. Engineers need to construct a bridge across a canyon. Oh my goodness, same type of question. On the edge of one side of Q. So from one side of Q to the other side. The diagram is the view looking down on the parallel sides of the canyon and the proposed position of the bridge PQ. So PQ, that's what I want. I'm going to write a little R there. Why do you think I'm going to write a little R there? Because that was my capital R, so I may as well match them up. From point R on one side of the canyon, a surveyor sighted post P on the other side at an angle of 36 degrees. Thank you, there's my 36 degrees. After having moved 100 meters, which is them sneakily giving me a side length, she sighted P at an angle of 40 degrees. Right, now, I'm fairly sure out there you're now saying, hold on a moment, we can find this angle here, we're going to need it. Yep, so again, on my calculator, 180, I'm going to subtract from that 36 and 40, and that's going to give me 104 degrees. So the first thing I'm going to do is write 104 degrees, which is nice because I now have a side length and an angle that matches it. Yay! Find the required length of the bridge. So we've got to find this. Have we got that angle? We have. So the two sides, the two things I'm going to use are those two. So that one, and 36 and R. So let's put it into the formula. We're going to have little r over the sine of 36 is equal to the length of P over the size of its angle, the size of 104. Guess what we're going to do now? Oh yes, we're going to use my calculator. Menu, algebra, numeric solve, formula. R on the sine of 36 equals 100 on the sine of, 104. Comma R. Don't forget to tell the calculator what you're trying to find. It's not that clever. So there we go. 60 point to 2 decimal places 58. So in which case R is 60 0.58. And don't forget your units of meters. The reason I know it's meters is that was given in meters. And again, reasonableness, does that make sense? 60 meters, 100 meters, they're in and around the same order of magnitude. It sort of makes sense. Now, we've got the ambiguous case. Sometimes there are more than two answers, or rather, there can actually be two answers to find an angle. Okay, and basically, this has all sort of been shortcut, I think, in terms of the idea of using nsolve. I've never really used nsolve before, but when there are two triangles to be used, my view of it is just to use nsolve at the moment, and I'm going to sneakily skip over this and pretty much call that the end of this video. If you are interested in the ambiguous case in the other way of not using nsolve, then ask your teacher. Hopefully they will be able to explain. It's a little bit out there, a little bit funky, and probably not for most of the general maths students, right? So don't worry about it, just use the nsolve and life will be good. Thank you very much for watching. What was that, 22 minutes? Not bad. I will hopefully see you in another video. The next video is on the cosine rule, which I'm about to record. Hopefully that will also be useful. Subscribe to YouTube if you can. Tell your mates, tell your teachers if you found this useful, and hopefully I'll see you in another video. If not, take care and please stay safe.